Now, this question looks more intimidating than it really is, and the reason for that is honestly this information down here. So let's temporarily assume we didn't have all this there. How would we approach it? Well, our goal here is to find this theta value, which is this angle here. And whenever we're dealing with trigonometric ratios, sine, cosine, tangent, it's good to recall what SOHCAHTOA is, which is this acronym that helps us recall the relationship for sine, cosine, and tangent, all of which have to do with opposite, adjacent, and hypotenuse sides. So from theta here, we're going to identify, in my opinion, the easiest of the three, which is opposite. Then hypotenuse is the one that's across from the right angle or not, or actually I should say the one side not touching the right angle. So that's over here, which we don't know that length right now. And then finally, by default, we have adjacent. So which trigonometric ratio relates the two sides that I do know of opposite and adjacent? Well, that's tangent. And it's very important that when we're writing the ratio, we do it in the order of the trigonometric ratio. So in other words, we need opposite on top, adjacent on the bottom. So opposite over adjacent. And now our goal is to find theta. And how do we get theta by itself? Well, we undo tangent, not by dividing tangent, but by doing an inverse tangent. And normally you won't see this, but just so you can get an understanding of what we do, I'm going to show that you do that on both sides, just like you would do with pretty much everything in algebra. And now we have theta is equal to inverse tan 84 over 432. So now let's go ahead and put this into the calculator. We'll go to Desmos. Obviously, you can use your own calculator if you want. And I'm going to click on the keyboard down here in the lower left corner and then click on functions and we'll choose inverse tan. And I'll do 84/432. Now, you notice this 0.19. What's really important is to recognize that they're talking about theta in degrees. And you could even see it here, 11.2 degrees, 78.8 degrees, 11.0 degrees. So we want to make sure we're in degree mode. So let's click on this wrench here and notice we're in radians. So we're going to click degrees and it gives us our answer now in degrees. And we want to find theta to the nearest tenth. So let's go ahead and look at the tenths place, which is the one directly to the right of the decimal. And then we look at the place to the right of it, which is a 0, and that tells us to stay. In other words, we know we get 11.0 as our answer. And so we could just type that in and that's our answer. Now, if that looks familiar, it should, because 11.0 is right here, and we did do tangent from there. And notice if you just take 84 and divide it by 432, we get about 0.2. So it's a little confusing, but they're basically saying, okay, if you would have recognized which trigonometric ratio actually gives you 0.2, like what do you have to do with 84 and 432? Well, you got to do this divided by this. 84 divided by 432 to get 0.2. And so that was opposite over adjacent. So it's got to be that the angle is this 11.0. I guess you could have gotten it, but I think our approach was actually more straightforward. So 11.0.